All right.
Okay, let's see.
Ready?
Yep.
All right. So does anybody have questions on part 1?
No, I don't.
Let's see. I think I have a question on this one. Is there one other question or no? No, I guess I'm good. I thought I had one, but maybe not. No, it looks like I'm good.
Okay, good. So then part 2, does anybody have anything they want to go over on that? Do we need to go through each one?
It's pretty straightforward with the formulas once you got the formulas down.
Once you got the formula, I think, yeah, it's pretty good.
Yeah, this one I think was probably one of the assignments that I felt pretty good about, but then when I went, just thought to myself, okay, so what did I learn last week? I had to actually go back and look at all of the stuff I learned last week, because I don't think that there was a whole lot of correlation between the two, honestly. I felt like I was learning a whole new concept.
Yes.
And so when, maybe next lesson or the next lesson, when they decide to put it all together, that's when my mind is going to turn to Jello.
Yes.
Well, the answer for number 6 on part 2, what are the 3 assumptions? Those are the same 3 assumptions when you're conducting a hypothesis test. So I feel like I'm starting to go in circles again.
And it was the same exact thing we answered in number 4.
Right. Yes. Yes. Yeah, I looked at that a couple times, went, wait a minute, didn't I answer that question?
Yeah.
Yeah.
Yeah. And another thing that confused me, just a heads up, I already started the homework, and one of the questions in the homework says, you know how it uses it and then it jumps back up and it says, okay, use this to answer questions 10 and 11 or something.
Right.
Yeah.
But it wasn't 10 and 11. Because 10 and 11.
The homework.
Or was that
there was something on the homework that was weird, right? Because I did the homework too.
Yeah.
It told you to use the data from other questions, but I think they just cut and pasted that, because it, you know how sometimes we do the whole set and it's like, here's a problem, and then they want you to do all 5 steps, and then they do another problem and do 5 steps. I think they just cut and pasted that all the way down. Now I can't find it for you, but number 16 on your homework. I don't think it's supposed to do questions 10 and 11. I use the data from questions 14 and 15. So just a note for you.
Yeah. Yes. Yes.
Okay. Well, I haven't gotten to the homework yet, so question 10 and 11.
Well, question number 16 asks you about the relationship between questions 10 and 11.
Oh, okay.
But that's a whole different problem that you've already, and honestly, questions 10 and 11 don't really mesh with a relationship. So I think it just meant 14 and 15.
Should have been 14, 15. Yeah, that's what I used.
Yeah,
so.
That's kind of what I looked at, thought too. That was typo.
But I had to go back and read through every one of them, because I'm like, of course I'm going to do this wrong. But
Well, that's what I went to the exam review last night with Sister Wilkinson, and 3 of the problems that I got wrong were just because I had read it differently. When she read it and explained it, I just read it wrong.
Right.
Right. I know that makes a difference if you can read it right.
Yeah.
Yeah. And that's part of the problem is translating it into English so it makes sense.
Yeah.
My friend did. She said, "What are you doing right now?" And she texted me, and I told her that I was like finding the margin of error for the 90% confidence, and so I just told her that was the question I was working on, and she goes, "What language are you speaking?"
Yeah, that's right.
Yes.
That's funny. So.
Anyway.
Okay, well, so are there any other do we need to go through each one individually, or everybody feels pretty confident in what we're doing?
I think we're good. We should
Yeah, I think we can just go right to
try
the quiz.
try the quiz and see how we do.
Yeah.
Right. Let's see, group 10 meeting quiz.
Yep.
Meeting quiz.
Make sure I pull up the right one. Christy has me nervous now that she pulled up that one once. I'm like, okay, do I have the right one?
Right.
I did, but it all worked out, so it was fine.
It did. It did. All right, is everybody on question 3 or not yet?
Okay, ready.
Okay, let's see. So we're supposed to round to 3 decimals and not round till the end. Okay.
It's going to take me a second to wrap my mind around it, math again this morning.
Yes.
Yeah, well, and to work it all out, that'll be what takes us time today, is just working out each question. So I've got to pull up my cheat sheet to get my formulas out.
Okay. So
Equals.
I need a confidence.
%.
And I've got it whenever anybody else is ready.
I do too.
I do too, but I don't know if it's right.
Well, I don't either, but I've got something.
So what does everybody have?
16.45.
So I have 2.
Uh-huh.
Woohoo.
Yeah.
Okay, 16.45. Nice job.
Mm-hmm.
Ooh.
It says round to 3 decimal places, so do we have to put a 0?
Yeah, do you?
I guess to be on the safe side, we could.
I did, just to be safe.
Okay.
So 450, you have 450 then, right?
Yeah.
Yeah. Okay.
Yeah, that's what I have too.
Okay.
Ooh, I don't know the next one.
Okay.
I'm trying to look at my definitions. Which of the following statements is true?
Let's see. Point
Okay. So
estimator.
2 times 2 squared is a squared is a point. So bar x is a point estimator of mu, isn't it? Let's see. What is that? point estimator. Isn't that term? Point estimator for the population. So isn't that? Let's see.
And then I put X bar as the definition for the point estimate. Are there different point estimates?
Let's see. I'm gonna get that. What about that cheat sheet, sister?
I didn't. That wasn't really on. Like it didn't say that they were estimators. It just said.
It says point estimators are mean, standard deviation, and variance because they are just one number, 1 point on a number line that is used to estimate a parameter.
Okay, so a parameter.
So a parameter is.
Mean.
Go ahead, Christy.
Is the mean a parameter? That's what I missed on the test. She emailed me that, and I missed the.
Go you back, Cleo.
Well, in the chapter 3.1, section 3.1, it talks about point estimators.
Point estimators.
Tell me again what is 3 point what?
3.1.
Right in the very front. Where that little,
yeah.
So you got the sample statistics and you got population parameters. And the
Right.
X bar is the point estimator for the mu. So that number 2, right? The point estimator. Except for it confuses me when it does it backwards, because then doesn't that mean the same thing?
Okay, point estimators are just one number.
That is used to estimate a parameter.
So is that not saying that X bar is the point estimator of mu?
Mu. Isn't that what that's saying?
I think so.
So is it backwards the other way? So when it does it backwards, that's where I'm stuck now. I'm like, well, what is it when it's the other way? Because
No, the mu isn't the point estimator of the bar X.
The bar X.
The mu isn't. The mu is a.
Okay.
Not a
just
point.
making sure it's not confused. I'm not getting it confused.
So is the standard deviation the point estimator for the sigma? That's not a stigma.
So
but
an S would be a
might
point.
be today.
The standard deviation is the point estimator for sigma, and the variance is the point estimator for sigma squared.
Yeah, but it would be an S. That's
yes.
Yes, it would be an S for the sigma, because S is the statistical one, whereas sigma is the parameter, the population one. So I like how they broke that down in that chart. If you think S statistic and P parameter, then you can separate those two the symbols out that way.
As long as you remember
which ones go on which side.
Yeah, I better put that chart in my notes, probably.
That needs to be on my single page notes.
Yep.
I'm hoping we get to add another page. So,
I hope there's.
By the fourth test, I get 4 pages of notes. That's my hope.
I hope so too, but I feel like in the syllabus it says 1 page of notes. We're going to have really
really small notes.
We're going to need our magnifying glasses.
Yeah.
Okay,
so we're going with number 2.
With number 2 is what I would say.
Okay.
Yeah.
Go your bed. Go your bed, baby.
Point estimate.
Okay, so Gina wants to construct a 95 confidence interval for GMAT score. She knows the standard deviation is 113. Sample size is 64. And then bar X. So bar X is
mu.
Mm-hmm.
Okay.
Yeah. That's where it's confusing because it wasn't before, right?
Mu was the little kind of big U, funny looking Sue.
Well, and it had its own thing. The mean, the mu had its own thing. Well, now the bar X is the mu. I get confused.
Right. Yeah.
So
okay,
the
so
point estimate is 526.
Yeah.
Yes.
All right. So
Three divided by the square root of 60.
All right, I've got something once everybody else does.
I do too.
I do too.
Okay, go ahead.
I got 27.68.
What?
I do too.
Yep.
27.
Yeah,
Okay.
27.685.
5.
Yep, thank you. I would have rounded to 2 for whatever reason.
Okay, so wait, I just did the confidence interval, I guess. So tell me what so it's,
We were asked for the margin of error.
okay, so what's,
It's the exact same equation we used to get the first question of 16.545. So it's the
M equals,
the margin of error equals, no,
oh,
that's got to be off to the side. M equals, and then you have the z-score times
1.96 times 113 divided by the square root of 64.
yes.
Okay, I was doing the confidence interval. So hang
But
on
you
a
need
second.
that on the next one, I think.
Yeah.
So.
Okay.
Okay,
You
so
do need that, yeah. You need the.
So then you're going to use that score to figure out what those,
That's something in
Alright.
statistics that if you don't have the first step right, then you miss like
You miss.
5 questions.
You miss everything. Yep.
27.685, so the whole 3 decimals.
Right.
685, yes.
Okay.
Okay, so this is just asking for the lower limit on this one. So we're going to use the minus.
all right.
Are you working out the whole problem again? Or are you just subtracting it?
Just subtract it, right?
Oh, and I didn't. Okay, tell me how you just do. So tell me what you got, first of all.
85.315.
What? 498.315?
Oh, I subtracted it from 113. That's my issue right there. That wasn't.
So what did you just?
Once you figure out the 27.685, you can just add it and subtract it. That's what.
Yes. Yeah.
From what? See, that didn't.
525.
520.
526.
Yeah. From the point estimate or mean, mu, whatever. Yeah.
Okay, somewhere in the reading, I totally missed that step because I have been working it out all week long.
Well, because with that thing where it has X plus or minus, the plus or minus, that rest of that equation is
the Z, whatever.
Right. So it's actually just a more basic form of that is X plus or minus M.
Yeah.
They show you both of those in the textbook. So we've already figured out M.
So did you put 315 or did you put 323?
No, 315.
315. Left the 315. Okay, yeah.
We're not a sample size, so you don't have to round up.
Okay, So if we know, I'm just going to make a note in my notes. If we know X bar, we use formula X bar plus or minus.
Right.
And is that called, is that the M?
The M.
The M.
Plus or minus M.
But we also know that the M equals the z-score times sigma over the square root of n.
Yeah, I have that written down. I've written it down 25 times this week. That never ever clicked in my brain. So. Okay, so question 7, the answer is 498.315.
Right.
498.315.
Okay. Yeah, I usually do things the long way.
Way around.
So then in my brain, the upper limit is going to just be the 526 plus 2768?
Plus the 27 points.
Yes.
Yes.
Plus 27.68.
Mm-hmm.
Okay, so that one's, everybody have it, I assume, but me?
Yeah.
553.68.
685.
685.
685.
See, how did yours come out with 685?
Did your calculator go all the way out to 3 decimals? It should take you 3 decimal places. Yeah.
And maybe that's why I always do it the long way, because no, mine just went to 553.68. I put in 526 plus 27.68.
Yes, do 685.
685.
685.
Yeah, mine did not give me the 5.
Yeah.
That's unfortunate. So maybe I wonder if I did it the long way, if it would give me the 685.
Yeah, I wonder. Because you'll need them. You'll need them. It'll throw off all your answers.
Right. And so let me just try it real quick. Yeah, see, I may have to do it the long way because that gave me 685. That's unfortunate because I like your guys' way a lot better. Okay.
Okay, so what happens with the confidence interval if she increases the sample size?
It decreases.
As the level of confidence increases, the width, and that's what it's asking, right? The width increases.
No, doesn't it decrease?
No, it says.
If you
I know number 10 on the homework, or is that the homework or the preparation? I don't know which one.
preparation.
As the level of confidence increases, the width will also increase.
The confidence margin narrows, though.
The margin of error decreases.
The margin of error gets smaller when your sample size gets bigger.
So
Right.
The width of the confidence interval is different than
The margin error.
Yes. So the relationship between the sample size and the width of the confidence interval will decrease with this increase of a sample size. But we're talking about 2 different things here. So we're talking about when the relationship between the level of confidence, which is that chart, the 90, 95, 99, that one.
I think the width of the confidence interval decreases, and I'm not looking at any notes. I'm just thinking it out in my brain. So if you guys have it in notes somewhere.
Yeah, I have it in notes.
Yeah.
Okay.
But I would think it would decrease because if your the sample size increases, and as your sample size increases, you're able to narrow that mean down. From
what happens to the width?
So
this is from.
So your confidence interval, the plus or minus 3, you might, if you have more and more and more people, you'll be able to be more confident. So that should decrease, shouldn't it?
Brother Cromar's notes, what happens to the width of the confidence interval, and that's what we're talking about here, the width of the confidence interval as the level of confidence and sample size increase. And he says, answer, as the level of confidence increases, the width increases.
Okay, well,
So,
Okay, is
and,
that
that's what I have in my answer. They asked that similar question in the homework. If you look at
number 10.
yeah, look at number 10.
Yeah.
of
The
part
homework or
2?
the preparation?
No, the homework. So if
Okay,
you-
well,
oh, let me see if there's one in the preparation. Hang on a second.
I didn't get the homework yet. So.
It wasn't in the preparation that I saw.
Okay.
Number 10 in the homework?
Yeah.
Hang on. Number 10 in the
Okay.
homework. Yeah.
So I put, let me look at
So
where's
write those down because those are different and they're confusing. I'm not, we're talking about different things and I don't have it all straight in my mind. I just
Right. So if
wrote-
you, well, see that, and if you increase, I guess I'm thinking of after the fact, and that's the issue. The way my mind is working is I'm thinking, well, if you get more samples, you'll have more, you'll be more confident. But I forget that all that we are talking now is prior to pulling any samples.
pulling. Right.
Yeah, they haven't even pulled any samples yet. So,
Right.
because
But also your
because then
margin
your
of error.
probability was 1 or 0, like they said. This is before we flip the coin. So
Yes,
if we,
before you flip the coin.
want to increase our confidence level and make sure that our point is in the middle,
In the middle.
somewhere in between our
Uh-huh.
confidence level, then we do need to increase our sample.
Increase.
That makes sense, sort of. If I tell myself it makes sense, maybe it will.
I just memorize the facts. I can't.
Yep.
I'm not going to try to think. Let's see. Has this worked or not worked? What's the rule?
Okay, so can you say it one more time for
Okay.
me to see if I can make it?
What happens to the width of the confidence interval as the level of confidence and sample size increase? And so that answer is that it increases.
So if we increase the confidence level, the required sample size also increases.
Also increases. And also, yes, the width of the confidence level. Yeah.
Okay. So we are going to increase number 9.
And that was the answer on number 10 in the homework as well. So, right. Did you got that answer too, right?
Yeah, I
Okay.
did get that answer in my homework.
Yeah. Okay. So
Okay,
But then
see,
the next one.
my thinking is I have to really think hard because a percentage to me, so it jumps to this one. So when I increase my confidence level, that means I go from 99% or from 95 to 99% because I'm more confident, or does that mean that I'm increasing my confidence level, meaning I'm widening the gap so I go down to 90% so that I have more confidence? Does that make sense?
Yeah, I'm still sorting this. So,
Because I don't know. When they just say increase your confidence level,
Well, so if your margin of error is small, does that mean your confidence level is good? Because there's less margin.
of error. Mm-hmm. Yeah, I would think it would mean.
But it seems like I wrote down that if the z-score is increased, then the margin of error increases.
Well, and I have that, it says, because I wrote that down, when the sample size increases, the margin of error will decrease. When the sample size decreases, the margin error will increase. I mean, and that is the margin error and the confidence level, they're two different things.
they're different things.
different things.
And that's
different
what we
things.
need to remember on number 9, because that's what I went to was the margin error, but we were doing the confidence level.
Confidence level.
Yeah.
Which, for just the they would seem to be the same thing. To me, they seem that
They seem like they're the same, but they're
They're not.
different.
They're not.
No.
Yeah.
Yeah,
They're not.
They're different things. And the confidence level only refers to those 3 percentages.
Yes.
Yeah. So how
Well,
accurate are you?
Whatever it is.
whatever
Yeah.
that percentage is, it can be different, but
Right.
See, the confidence level is different than the confidence interval.
Yes, the confidence interval and the confidence level are 2 different things. And that's why it's getting confusing too. Which is the next question. When I
Right.
so
talk
the
about
confidence interval are the like the 2 points, your upper and lower points.
Okay, so
And your interval is
level
the
is the
percentage.
the percentage.
So
So,
I
Is
think
that-
so that chart,
question
you know, when you made the
worded
chart,
wrong.
you remember seeing the chart where there was the 90%, the 95, and the 99?
Yeah, those are the confidence levels.
That's the
Mhm.
level of
And the
those are the
level
levels
is
of
the
confidence.
z-score. The confidence level is the z-score.
Mm-hmm.
But the interval is okay, so this question number 10, I think should not say what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval, because 99% is not a confidence interval. It's a confidence
Right. That question.
level.
So yeah, I don't know if that question's very well worded. That next question. What would happen to the width of the confidence interval if Gina changed it to a 99%? Shouldn't that say confidence level?
Yeah, maybe interval and level mean the same thing, and I
Maybe
just
they
am
do.
reading it wrong.
I don't know. Confidence interval is an unknown parameter.
So number 1 on the homework, and I know Sherry, you haven't looked at it yet, so let me read it to you. But it says, which of the following confidence levels will yield the narrowest confidence intervals for the same analysis? 90, 95, or 99. And on that one, to yield the narrowest confidence level is 90.
Mhm.
So this one, is it going to
Yeah.
increase on question 10?
The narrowest confidence level is 90.
Uh-huh.
Yeah, because that's where you've got your
Are you still there?
I don't know.
We're-
I don't know.
I'm gonna have to go back and read. I thought I had this all figured out.
I did. I watched him and I said,
Yeah,
oh,
I thought, oh, this is not that hard. And I went through it and did really well. I didn't even watch the other dude's video.
I watched them both and I thought, okay, I got this.
Oh, I better go back and watch the video again. I know these answers are right because I checked them up against the answer key after I did them, but I can't explain it now. 90% of all 95%.
So what's the answer then for question 10
I
on the
don't know.
quiz? Increase?
What would happen to the width of the confidence interval if Gina changed it to 99% confidence? What happens to the width of the confidence interval as the level of confidence and sample size increase? So notice the figures from 95% to 99%. Does those increase?
In my brain, it increases. So usually if it's in my brain, it's probably that it decreases.
Is 1.96 smaller than 2.58? Because that's what we're
No.
looking at.
I guess we could.
Yeah, it's
So so like in the homework, when we did like 7, 8, and 9, well, 8 and 9, our confidence level went up and our margin, our width of confidence interval, I guess, increased. So is
Yeah.
that asking the same things as it is
Yeah.
on questions 8 and 9?
Yeah, it increases.
Well, and I guess if we were really questioning, we could take this question that we just did with the X bar or the
Just see what happens when we do it out.
Mhm.
and you could plug it in and then we would know, right?
Yeah.
So
But
you
we
want-
did that. You do that on the in the preparation when you did let's see. So did we do that with number 8 and then again on number 11? Were those the same? Yeah.
That's changing the number. That's not changing the confidence.
So you created a 95% confidence interval with those same, that GMAT score, and then created a 90% confidence. And so then you can,
Oh, there's the 90. Okay.
yeah.
So if you
So-
punch in 2.576, which is for 99%, and you times it by the 113 divided by the square root of 64, the one answer that we got, the 27.685, plug this in with the 2.576, 99%, and you get 36.386. So that's that's an increase, right?
Mm-hmm.
All right. So we're all going to say increase.
Increase.
Yeah.
Yeah.
Is the 27.68, that's the margin of error. So we had the 2768 and then whatever Sherry came up with, the 30, whatever.
36.386.
But because that's bigger,
And that's only on one side of it.
right.
So the confidence interval is plus or minus that,
Well, it's
right?
going to have to be that much bigger
Gonna
on
be
each side.
wider.
On each side. So
Right.
it makes it wider.
Right.
Okay.
Because there's something like what Joy said, if your Z-score increases, then your confidence level widens, right?
Mm-hmm. Yeah. Mm-hmm.
Right.
So let's see. So if your
Go your bed. Go your bed.
Z-score increases, your confidence level increases.
Right.
Mm-hmm.
Yeah, I thought I wrote that down somewhere, but now I can't find it. So
I thought I did too. I thought I even typed it in my notes, but I sure don't have it now. So.
Yeah, I write down, I copy down all of Brother Cromar's slides in my notes.
That's probably smart. I thought I understood it as he was doing it. I was like, okay.
Yeah.
So you wrote down that if the Z-score increases, the what also widen, or the interval widens?
So I didn't write, let's see. What I wrote down was what happens to the width of the confidence interval as the level of confidence and sample size increase. And though his answer was, so that was his question, and his answer was, as the level of confidence increases, the width increases. And then he says, notice the figures of 95% and 99%. And I don't have the screen in front of me, but I'm assuming he was talking about those Z-scores because they increase.
Yeah.
Yeah.
Okay.
All right.
So sample.
All right.
All right. So, okay. Back to this now.
Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is sigma 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So you take n equals
Mm-hmm.
Yes.
the
1.96.
square it, because I haven't always done that.
On this one, you always round up.
Right.
Okay.
Everyone got it?
Yes.
Yeah.
246.
Yes.
Okay.
Oh, brother.
Is this from the last week?
Salaries.
Yes. This is where I told you the Jello was coming into play.
I'm gonna have to. I didn't print that part up. Dang it.
Salary
Okay.
of actuaries is 100,000.
Lower limit of this 95% confidence interval. So
So we're gonna have to walk through this because I don't even have the formulas. I did not print up the formulas that I wrote down.
So we have 111,000.
That's going to be that's actually going to be the mu this time, right?
Right.
The
No.
100,000.
the lower limit of the 95% confidence interval. So we need to find what that confidence interval is and subtract it from 111. Correct? 111,000.
Oh gosh.
Okay, hang on a second. What are the figures here that I'm lost? Hang on a minute. Let me think.
A lot of numbers.
I know there's so many. Okay, so we don't use the 100,000. We use the 110,000, the 111,000. Explain that to me, because I think this is where I got confused last time, and I was. Why aren't we using what they hypothesized?
Well, so our mu is the 100,000. That's what we're trying to prove, or either
Accept or reject.
reject. But so how come we use? Why do we calculate it from 111? I guess that's where I get.
Because we did the sample and we found that their salaries were 111.
Okay. Okay.
So
we have to go. X bar is 111,000.
Mhm.
And then the standard deviation is 36,730 with a sample size of 36. So now are we doing the
So multiply 111
minus?
Yes, because we don't know. Well, that's just it. The question that it's asking right now is find the lower limit of this confidence level interval.
Okay, but you've got to figure out the first. You got to do the first part of this.
So you do the X bar minus.
So you do you got to do the X bar times the mean. No, times sigma divided by the square root of the sample size.
So we're doing the lower. So X bar minus the 1.96 times 36,730 divided by square root of 36.
So our X bar is the 1.960?
No, the X bar is 111.
Bar is 111. But if I guess my question is if we're just finding a confidence interval, so in order to find the confidence interval, we need to find the margin of error. and subtract that from the 111,000.
Mm-hmm.
I think for 12, it is what is the lower limit of this 95%?
Yes, yes, you're looking for, yes. So you've got to get that first figure and then take it from the 111.
And our first figure is the X bar
1.96
Z times sigma divided by the square root of n.
Right.
Uh-huh. Yep.
Christy, are you agreeing with that?
Well, I'm trying to, where did you get that X bar in your equation?
The first thing is
X bar equals 111.
I know, but none of the equations we used this week had X bar in them.
Yeah, they all do.
They did. The confidence interval. The confidence interval is.
I get that.
X bar minus n or X bar plus n.
I can't remember. So the one you're doing is, because we've got to find the confidence interval.
Yeah, so 1.96 times.
What? 1.96.
1.96 times.
Oh crud! I typed that in wrong.
I'm not doing.
Okay, so to write out the formula, it's going to be 111,000 minus 1.960 divided by 36,730. Oh, not divided by, that's times. That's times. Then divided by the square root of
36, right?
Is that the right formula?
That's what I was trying to do.
Yeah, I think that's the right formula.
1.96.
Ooh.
So
99,000.
99,000, right? Is that what you came up with? You get the 99,000.
So has everybody got it?
Do you need 99,001?
Yes, because round to the wholest, it's going to be 2. Christy, do you have it? Let's make sure everybody's there first. Not yet?
No.
Okay, well.
Maybe I'm doing it very wrong here.
Because are you thinking different than what we're thinking?
I don't even know what I'm thinking right now. I have $99,001.
Yeah.
Okay. Yeah, that's what I have.
And it says round to the nearest whole number, so we need to put in there 99002.
Right.
Mm-hmm.
Would be the lower limit because we subtracted it.
Because we subtracted.
Mm-hmm. And do it the other way.
And I have to work the whole thing out to get the right answer.
If you just can't plug in your other one.
It doesn't work on my calculator, remember?
That's right.
Oh, maybe it would.
Well, yeah, I do mine separate. I find the middle one and then I just subtract it from
add and subtract. Yeah. So if you're just taking the 1.96 times the
margin,
times the 3 times the sigma divided by the sample size. Yeah.
And remember, that's when mine didn't round to 3.
That would just round that way, so you plugged it in the whole way.
I'm still not wrapping my brain around that. That should be the simplest way, and in my brain it isn't. So, all right. So, does everybody have the next one?
Yeah, then 122.
122,999.
Mm-hmm.
999 or 998? Because I got 998.46.
But
then I rounded, and then I rounded it.
Oh no, we don't. Well, it says round to the nearest whole number, but this is actually not asking for
a sample size.
So we don't round it up. right?
Well, it just says it in the answer round. I mean, the question round to the nearest whole number.
Yeah.
But that would be rounding down.
Well,
Oh,
no,
I
if you
just,
round
yeah. 998 then. I would say it was 998.
We're
Yeah.
still. Oh.
Because we only
If you
when
round-
it asks for a sample size, you can't sample, 0.46 of a person. You can't.
Right.
So you have to
But
round up. But
this
this
is
isn't the sample
this is a-
size.
Right.
But if you rounded it up anyway, it still would be 9 because
Right.
it's
It would be.
0.467. So if you round the
Mhm.
7 to the 6 and the 6 to the 4,
But the nearest whole number is actually rounding it down.
Because it's a 4.
4. Mm-hmm.
but it's a 467.
Right, but
I
that's
don't know.
still less than 5.
Yeah, still 4 is less than 5. So
Okay,
then,
okay,
so that's,
you're
so it
right.
wouldn't
Okay, so 998.
If we
Yeah,
get this
nice.
one wrong, I'm pitching a fit.
Yeah, because I did.
Right.
Okay,
because
so
of the
we're
round-
in agreement that it's 122,998.
Right.
I
Now,
think
what about the one up above? What was it?
We 2. That one would have been a 2. Right.
002.
That one would have been a 2.
That one would have
Okay.
been 2. 99002.
because that was 0.54.
Right.
So it rounded up
So-
anyway.
Yeah. So when you get to 5, then you
Ooh.
round. Go high.
Okay. Okay. Oh.
Okay.
Oh my
I
gosh.
think I like the question. I think they let us end on an easier one because I think I like this one. I think we know this one.
Right.
And if not, it's right in my notes.
Right. Yeah, that's nice.
There are 3 requirements that need to be checked when computing confidence intervals. They are, so a sample, random sample,
Drawn from population. Sigma is
An X-
known. All the X bar is normal. All the above.
we're going to say all of the above.
All of the above.
All right. Now let's see what we
Get
did.
brave and see what happens.
Yep.
Oh my goodness. Oh, we missed a couple. Let's see.
Oh,
Oh,
Was it the
that's
rounding?
rounding.
Was it the rounding?
Yes. Oh, and it was it was number 9.
okay.
So I
The
think,
rounding. We're not doing this rounding right.
I wonder if Sherry was right on that one because I have the same thing in my notes. So question 9, what would happen to the width of the confidence interval if Gina increased the sample size? And in my notes, I have when the sample size increases, but then I have the margin of error will decrease.
But if your margin of error decreases, then the width, that is the width of your, I see, this is the width of the confidence interval, that I think they're using terms that are
Yeah, we're not.
ambiguous
Yes,
here. I
they
don't know
are.
what it means, but
They are.
that's it. Like, if I were just to think about it, if you increase the sample size, then your confidence level width you should be more confident. So the width of your confidence should be able to be narrowed. So you could say, oh, I am between, I am 95% confident.
Right. Right.
Just get her both.
So it probably should decrease.
So what are
Well,
we?
there's always a change. If you change your confidence interval, it's going to change. So it has to be, the only other option is decrease. Doesn't it have to change?
Why did the homework say that? That's,
Well, that's
now
what-
now
I
I'm
That somebody needs to, ask.
I'm going to open up that homework assignment again and see if I can find that answer, because it was almost exactly word for word that problem on number 10. And so what do you notice about the relationship between the level of confidence, the 90%, 95, or 99%, and the width of confidence interval? And the answer was, as the level of confidence increases, the width increases. So
No, that's question 10, though. We missed the one about the sample size.
yes, that was okay, but we missed that one too, didn't we?
No, we got question 10 right.
10, right? It's just 9. As
Yeah,
as your sample size increases,
Okay, so
width.
there was one of those. There was one of those in here too then. What do you notice about the relationship between the sample size and the width of confidence interval based on questions 10 and 11? Which were, that was that one that you were talking about, Christy, that was actually for 14 and 15.
Well, in my notes, it says if n increases, the fraction of sigma divided by the square root of n decreases, which leads to a smaller margin of error. So if n increases, the fraction, so if your sample increases, that fraction decreases.
Decreases?
Yeah,
Well,
because you have a smaller denominator.
Where did those?
And I think, so if you read 16 on the homework, which I think you just did, Joy.
Yeah, 16.
What do you notice about the relationship between the sample size and the width of confidence? The answer is, as the sample size increases, the confidence interval width decreases. That's what Sherry is saying.
Yes.
Yeah.
Yes. Okay. So those are going to be opposite each other.
It's confusing.
Oh man, I'm telling you.
What other one did we miss?
We didn't miss
all
any
those
others.
We
rounding
missed
ones.
12 and 13.
We missed all those rounding ones. All those ones that we were trying to round, we did it wrong. We got
No,
half a
those are
point.
right. We got 0.5 out of 0.5
Oh,
points.
0.5.
Oh, 0.5 out of 0.5. So we
Oh,
did.
okay. 0.5. Oh, okay. Those are right. So we missed. Wait. So what did we miss
So
then?
it's
Just
number
that
9.
one.
I just saw the zeros.
Oh, I know. I
on
did
all these
too.
other ones.
Yeah, we
Okay,
got
No. Oh, no. So number 6 is wrong.
6. No, we got 13 out of 14.
Yeah, we got 6 right.
Oh, then I must.
27.
What did you write down?
27.685.
Okay.
Yeah.
27.
I'd say we got 13 out of 14, but as I scrolled down, I just saw all of the zeros and the
Yes,
0.5,
yes.
and I thought, oh my gosh, we did terrible.
They were just point ones.
They were fine.
So, yeah. Are you guys going to go back and retake it
Back and retake.
Yeah.
Yeah, I am.
just to get that 100? Okay.
Yeah.
Are you doing it now?
Yeah.
I'm
No,
gonna
it's
do it
like
as
a
we go.
0.5 of a 0.5.
Right now
of
while it's open. Oh, I know. I don't like seeing those zeros. Those throw me. Like, no,
Yeah.
I didn't miss that one too.
Well, and I thought today was going to be really quick. So I'm a
I
little
did
worried about
too.
Thursday.
Yeah.
Oh, I know.
Now, is it Temple Week or was that last Thursday?
The stake has asked us to go to the temple. The stake presidency wants all the bishops and their wives to go to the stake or to the temple with them on the 24th. So we'll just go on that Saturday. So
Okay, so we're good for this Thursday. We're good.
Yeah,
Okay.
I have to get my taxes done that day, but so I won't be able to be like 2 hours. I
Super.
to leave at, I have an hour and a half I can spend with you. So
Let's hope that one's not
hopefully
too bad.
that's
then.
all we need.
Hopefully that is all we need.
And that's on
Have
what
you
day?
started it yet
That's
for the-
Thursday.
Okay. So this week, do you want me to go ahead and invite this week? Let's start taking it a week at a time. So
That's
I
great.
will invite again on Thursday, and
Okay.
then whoever can take
Yeah.
next week. So I'm going to go ahead and stop the broadcast.